Now, here you have two-dimensional world, then you have just two elements in a consumption bundle. If you are talking about n-dimensional world, we will have n different goods in a consumption bundle. So, is there any way that we translate this problem from n-dimensional problem to one dimension? What we are interested in, that whenever we compare two bundles, we should able to rank them, and those rankings should be consistent over the whole consumption set. So how can we rank? Do we need, we can rank them just like first, second, third, fourth, and we are not really interested in first, second, third, fourth. We are just interested. Can we say here, let me say just here, that this has value 10, this has value 5, and this has value 1. So if we compare these two numbers, since 10 is higher than 5, it's ranked higher. 5 is higher than 1, it's ranked higher. So instead of dealing with these things, dealing with 10, 5 and 1, because these are one dimensional while these are n dimensional, it's a lot easier. So what we can do, we can define a function.
Utility function.
We can define a utility function. Okay? And what is the utility function? What does this utility function does?
A function describes
it represents a person's preferences. It represents a person's preferences. Okay? So let me give you the definition of utility function. The function u that is, I'm talking about a function u. A function u is from set x to R, and this set x is consumption set. From consumption set, and what is this R? Represents
real number set.
Real number set. From consumption set to the real line. So the function is a utility function. Okay, this is a utility function that represents preference relation denoted by this. This is a relation. If for any two bundles x and y in consumption set, what we have, let me change it to if and only if. What we have is so the function u from the consumption set to the real line is a utility function representing the preference relation if and only if with any two bundles from the consumption set. And what we get, if x is at least as preferred as y, then we get ux is greater than or equal to u of y. Other way around, that if u of x is greater than or equal to u of y, then what we get, x is at least as preferred as y. So now, instead of dealing with a bundle which has n goods, we are dealing with a particular number assigned to that bundle, and comparison becomes lot easier. Just compare the two numbers. Just let's check that will it satisfy the three properties. It will, because whenever you take two bundles, of course a number will be assigned to a particular number will be assigned to a particular bundle. So both the bundles will have their own numbers. You can compare those numbers, and when you compare, there are three possibilities, that one is greater than the other, or the second one is greater than the first, or these two are equal. so completeness is satisfied. Similarly, if you take a bundle and again compare it with itself, a number is at least as big as itself, so reflexivity is also satisfied. How about transitivity? Transitivity is also satisfied because take three bundles, if one is greater than the second and second is greater than the third, then of course first is greater than the third, implying that first is preferred over the last. So all these three properties are satisfied. Fine?
Yes, sir.
Okay? So you can prove it. I am not proving it rigorously. And how about preferences which do not satisfy the three axioms? Can they be represented by a utility function? Think about it. Again, it's good idea to try to prove it mathematically. Of course they won't. Let's take a person who has cyclic preferences, means orange, apple and mango that we used earlier. Okay? We will not have any such utility function describing this cyclic rotation. Why? Let's say assign it 5. Assign it 6. What would you do here?
Each of three utilities would converge to infinity.
Each of?
Each of the products utility would converge to infinity because one is greater than other, one is greater than other, one is greater than
That's
other.
one way to look at it. But what I am saying, just look at the assignment, the way we need to assign. That orange is preferred over mango. So then let's say you give it here 6. And you give it to mango 5. And mango is preferred over apple, strictly preferred. So here you give 4. But apple is preferred over orange, but 4 is not greater than 6. So we cannot have this sort of assignment. So I am showing it you through an example, but what I am saying is much more broader, that any preference which does not satisfy the three axioms cannot be represented using a utility function. Fine? Now let's look at it one more. Let's go back to the discrete example that I gave you, where we had ranked and we said 10, 5 and 1. If I say it is 100, it is 6 and it is 2, we are still these numbers and these numbers. These numbers is coming from a different utility function and these numbers of course coming from a different utility function. But let's compare these two. In both you get the same order. The complete order that you get is the same as the previous one. And when we are talking about rational preferences, what we are worried about? The complete ordering, that you take any two element, you should be able to order them, rank them. Okay? And that's true for any bundle. Okay? So that it doesn't matter whether you use this scheme or you use this scheme. You are describing the same preference. So what does it mean? That the utility function that we have talked about is not unique for a particular person preferences. Okay, it's not unique. If you get a utility function, you can definitely find another utility function. Let's say you just add 1 in that utility function, you get another one. Add again 1. Fine? So it's not unique. So let me give you again more general result, and the result is if the function u represents an individual preference, so of course this individual has to have rational preference, otherwise it cannot be represented by a utility function. Then any monotonic transformation, I will come to it, what is monotonic transformation. Any monotonic transformation of U will also represent the same preferences, same preference. Fine, is it clear?
Yes,
Let
sir.
me give you an example. Let's say that, again, it's good, you know, it would be simpler if you imagine a conjunction bundle with finite number of bundles. A conjunction set with finite number of conjunction bundles. And let's say you have ranked them, okay, and you have a rubber that you can stretch, you can shrink, you know, and you can stretch, you know, for different part, different, and on the rubber you have marked the position of different bundles. Now you stretch that rubber, what you will get? Let's say the original position will be given by a particular function, utility function. When you are stretching, you will get another function, but it would not change the rank. So that's what monotonic transformation does. That monotonic transformation preserves the rank. It doesn't change the rank. If one is greater than the second and we do a particular kind of transformation where this, with the new valuation, one remains greater than the second, then we do not have any problem, and that's what we are talking about. So what if you have little knowledge of mathematics? Let's say U is the function, utility function, and then monotonic transformation will be represented by V. What is V? V is nothing but G of U, where G dash is greater than 0 at all points. Fine? Is it clear?
It can be less than 0.
It can be less than 0, mathematically speaking it can be less than 0, but in economics by convention we use for monotonic transformation G dash greater than 0.
But for less than 0.
So what happens if it is less than 0 for the whole range? Then what would happen? It would inverse the ranking.
Yes, sir.
So in mathematics, when we talk about monotonic transformation, what we mean? G dash is greater than 0 at all points, or G dash is less than 0 at all points. But in economics, when we say monotonic transformation, what we mean is that G dash is greater than 0 at all points. Fine? G dash less than 0 is also monotonic transformation. So what we are doing, let's say this is the rubber and we are stretching it. Here are this. So we can stretch it in the different manner. That this part remains the same. This part, let's say here 1, 2, 3, 4, 5, 6 bundles. So what we can do, 1 we can stretch here, 2 we are keeping there, 3 we are keeping there, 4 we are stretching, 5 we are stretching a little less, 6 we are stretching. What we are talking about is that order, we are keeping the order preserved. Okay? And then we get another new utility function. This is fine with you? Okay.